Dear students, we have studied the reverse osmosis. Now let us read the next para. Osmotic pressure is generated when two solutions have different concentrations. When two solutions have same concentration, there is no osmotic pressure. Thus we can say that osmotic pressure pi depends upon the concentration, that is known as C. But as we are discussing colligative property, osmotic pressure depends upon the total number of particles of solute present in the solution, irrespective of the nature of the solute. Therefore, we can say pi proportional to C at constant temperature T. Therefore, pi is equal to CRT. Here, R is the gas constant which is used into the PV is equal to nRT. But C is the concentration which is molarity, that is mole per liter of solution, or we can say that mole per unit volume. Therefore, C is equal to N by V. N is equal to moles of solute and V is equal to volume of solution in liter. My dear student, please remember this liter here very much, because whenever you use this equation pi is equal to CRT, your C must be mole per liter. So whatever the concentration is given, you have to convert it into mole per liter, or if they have given you the mass in gram, you have to convert it into the moles, and you have to consider the volume of the solution in liter. Even if it is given into the milliliter, you need to convert it into the liter, and then you can go for the calculation. So this liter word is very important here. Now pi is equal to nRT upon V. By putting this C is equal to N upon V, we will put in place of C, now we will write N upon V. So we will get pi is equal to N upon V RT. Or if we take V this side, we will get pi V is equal to nRT, which is very similar to the ideal gas equation PV is equal to nRT. But we know that moles is equal to mass in gram divided by molecular mass. So if we consider it for the solute, then what we can write, W2 by molecular weight 2. Here 2 represent the solute. So here I have clearly written here W2 is the mass of solute in gram. Therefore, pi is equal to W2 into R into T divided by V into MWT. Here instead of N, we write WT divided by MWT. So this is your W2 and here you have your MWT2. That is what it represents. N, you have R, you have T, you have V as usual. So now from this equation we can calculate the molecular weight of solute, that is your MWT is equal to W2 into R into T divided by V into pi. So this is how we can understand the formula to calculate the molecular weight of solute using the osmotic pressure method. Thank you, my dear student.